Electric motors are the most important part of modern industry. From manufacturing plants to renewable energy systems, they keep the world moving. But like every machine, motors are not immune to faults. When a fault happens suddenly, the results can be a disaster, downtime, costly repair, and even safety risks. Electrical faults such as winding short circuit, broken bars, or partial demagnetization in permanent magnets can remain hidden in early stages. They slowly degrade the performance until they finally lead to total failure. This is where simulation becomes a powerful tool. By simulating electrical faults in advance, engineers can anticipate how motors will behave under different fault scenarios without waiting for fault to occur in reality. Simulation allows us to compare the healthy condition with faulty conditions. For example, an intern short circuit in a winding of a stator changes current distribution, magnetic flux, and torque ripple. These differences appear clearly in the simulated results, helping us to understand what to look for during monitoring. Once we know how faults reveal themselves, whether in current harmonics, increased losses, unusual torque ripples, or rising temperatures, we can design smarter diagnostic systems. Simulation provides the fingerprints of each fault, so real-world monitoring equipment can recognize them at the earliest stage. Early detection means preventing small issues from becoming big failures. Instead of costly breakdowns and production stoppages, companies save time, money, and equipment life. Simulating electrical faults is not just about predicting problems. It's about building reliability, designing better diagnostic tools, and ensuring motors deliver maximum performance throughout their lifetime. Through simulation, we turn potential failures into opportunities for prevention. That's why fault simulation is an essential step in motor design. In this course, we will simulate different faults in electrical motors in ANSYS Maxwell, and we will talk about tips of step-by-step simulation to apply the fault into the machines and compare the results of faulty machines with healthy ones. These days, you can see many papers and journals are about simulating faults inside electrical machines. So this course will help you to write your papers on this subject if you are a PhD or master student of electrical engineering with the field of machine design. If you need any further help in your simulation or consultancy in your projects, you can contact me via email or direct message in Udemy.